Hi, y'all. Welcome back. Last class, we talked about the quadratic formula, right? So we've talked about three different ways to solve quadratics. We can solve them by factoring, we can solve them by square roots, we can solve them by completing the square, and we can solve them by the quadratic formula. So we actually talked about four ways to solve it. All right. Today we're going to do something that I think you guys will find a whole lot easier. Okay. Today we're going to talk about how to solve a linear and quadratic system. So system meaning there's two equations in one problem. All right. And one of them is linear, so it's a straight line, and one of them is a quadratic, so it's a parabola, either an n if it's negative or a u if it's positive. Okay. You will have to have Desmos open for this lesson. Okay. It'll make your life so much easier if you have Desmos. So I have it pulled up here, and I even wrote on here to use Desmos. Okay. This is section 2.7, page 110 and 111 in your workbook. All right. So basically, all we're going to do is take these equations in all of these problems, and we're going to graph them, and we're going to look to see where they cross. That's basically all we're trying to do. Now, this will work for any two equations that you have. If there was three equations or four equations, this will always work. You can graph it, and then wherever those two lines intersect is your answer. Now, they might intersect once, they might intersect two times, they might intersect no times, right? So that's how we're going to determine our answer. So let's say we did this very first problem right here. It says determine the number of real solutions of the system. So real solutions meaning we're not going to have any i's in our answer, right? So if we graph it, we should be able to see it. So all I'm going to do is go over here to Desmos and type in this equation. So the first one says 3x squared. And I'm going to hit enter, and I'm going to type in the second one, 3x minus 2. So if you look, here's my graph, right? And I could zoom in, so you can see here's the linear one, the straight line, that's the 3x minus 2, and here's the 3x squared. And if you notice, no matter how far you zoom in here, these graphs are never going to cross. So since these graphs never cross, the answer to this problem is no real solutions, because they never cross, right? In order for there to be an answer, there has to be an intersection point. So there's no real solutions because the graphs don't intersect. Now, this problem does have two answers, right? It just so happens that they're not going to be real. Okay, these answers are going to be imaginary. So if we solved this by hand, if we actually figured out what they were, our answers are going to have I in them. Okay, so that's it for the first one, right? Determine the number of solutions. It doesn't have any real solutions. Okay, now the second problem says solve each system by substitution. We're not going to worry about that substitution part. All right, as long as we can solve it, I'm going to be happy. All right, now there's one catch. In order to graph in Desmos, we're going to make it say y equals. Okay, so the first thing I want to do here is get this y by itself. So in order for us to graph it, I need to get the y by itself. The first one's already good. So on this second one, right, let's say that I added the y to both sides. That would give me 2x equals 16 plus y, right? So now I've got the y almost by itself, but now I want to get rid of that 16, so I would subtract 16. So 2x minus 16 equals y. There is my equation. Okay, so now I have this first one here in blue that's ready to go, and I have this one here in black that's ready to go. So all I'm going to do is graph them both, just like we did the first one. So I'm going to type it in 2x squared minus 6x minus 8. There's the first one. I'm going to zoom out a little bit so we can see it. The second one is 2x minus 16. And then we could zoom in a little bit because it looks like they're going to cross down here. And if you click on Desmos, it will tell you exactly where they cross. 2, negative 12 is my answer to this problem. So this question has an answer, 2, negative 12. And we're done. Pretty easy, right? Desmos is going to help us out tremendously. Okay, Desmos will be a lifesaver for us. Okay. Now I told you that you are going to have to get y by itself. I kind of lied to you there. You don't even actually have to change it if you're using Desmos. right? It'll work. Like, see how I didn't change this? I kept it exactly the same, and it still gave me the exact same answer. All right? So I kind of played with you a little bit there at the beginning. But if you didn't have Desmos, so if you're taking the ACT and you don't have access to Desmos, you're going to have to get the y by itself in order to graph it on just a regular standard graphing calculator. Okay? So let's look at this second one. All right? So the first one's already set up for us, right? It's good to go. I'm going to change the second one. Even though we don't have to, I'm going to change it and get the y by itself, just so we can get used to doing that, right? I would add y, just like the last one. So 4x equals 2 plus y. And then I would subtract 2. So 4x minus 2 equals y. So now this one's ready to go. And we have the first one all ready to go. So once the y is by itself, you're good to go. Okay? So now they're both ready to graph. So we're just going to type them in. Negative 3x squared plus x plus 4. Hit enter. I'll zoom out a little bit so we can see that one. And then the next one is 4x minus 2. 4x minus 2. And now it crosses twice, right? It crosses once down here and once up there. So we've got our answers, right? We have one answer at negative 2, negative 10. And the other answer is 1, comma 2. All right? So once we have the equations, all we are going to do is graph it. Okay? All we're looking for. Where will these things cross? Pretty easy, right? The same thing will apply as if we were doing a word problem. I know word problems are not any of your all's favorite, right? Most people tend to hate them. But we're going to do the same thing. So it says revenue for a high school band is given by this function first, where X is the ticket price in dollars. The cost of the concert is this. At what ticket price will the band make enough money to cover their costs? So basically, we want to know how much should the band charge so that they don't lose money on this concert. Right? They have to make sure that they're charging enough so that it doesn't cost them money in the long run. Right? Everybody's trying to make money, so that's the same thing that this band is trying to do. So again, look at these two. They both have y already solved. Right? So we don't need to change them like we did up here. Right? I don't have to change anything because they're already ready to go. I'm just going to type them in. So negative 30 x squared plus 250x, so plus 250x. Now I'm going to type in the second one, which is 400. Whoa, I just hit my camera. 490x. 490 minus 30x. So if you look here, this looks a little weird, right? It's kind of hard to tell where they cross, but if I kept zooming, right, or moving this graph, it's going to cross at a couple of different points, and that looks kind of ugly, right? It looks super ugly, and it's hard to tell. But it looks like they're going to cross somewhere in here, right? 7, 280, and then it also looks like they cross again way up here somewhere, right? Like right in here. Everybody, hopefully you're with me. Right? It's really hard to tell on these graphs exactly where they're crossing, but you can just zoom in. That's the beauty of Desmos, right? You can just zoom in or zoom out. So we're basically just looking for where these cross. And it was 7, 280. So it told us right here that X is the ticket price. X is the ticket price. So this band, right, needs to charge $7 per ticket, and they have to bring in 280 people in order for them to break even. Right, so $7 per ticket for 280 people, and they would break even, right? They wouldn't lose any money. Now, they also might be able to charge a little bit less money, but they would have to bring in a whole lot more people, right? So if we keep scrolling this thing and we come up here, they could charge $2.33 per ticket, but they would have to bring in 420 people, right? So this band is probably going to charge the $7, because then they only have to bring in less people. Probably wouldn't be too bad if they have a big band. Okay? So again, all we're doing is graphing it. Nothing new, nothing different. All right? Okay, there's one last problem, and it is this one right here. Using a system to solve. This one gives you a whole lot of directions, right? So it gave us two equations right next to each other by writing a linear quadratic system and solving using the intersection feature of a graphing calculator. It's literally telling you to do the exact same thing that we've been doing. But now we're just going to do each one separately. So one equation is 3x squared minus 7x plus 4. The other equation is 9 minus 2x. I'm just going to graph those two, just like we did on all the other ones. So 3x squared minus 7x plus 4. Hit enter. Graph the second one, 9 minus 2x. Hit enter. And I'm going to have to zoom back, because remember I zoomed in really far before. And so here is this graph. And look, I can see where these two cross. They cross once right there, and they cross once right there. Alright, so the only thing I need to know in this problem, right, there's no y. Notice there's no y up here, so I just need to know the x values. So the x values are approximately 2.37 and negative 7.0. Whoops, I lied. Negative 0.70. There's my two answers. Okay? So, Desmos is a lifesaver. Desmos is your friend. When in doubt, graph each equation and find where they cross. Okay? You guys have a Math Excel assignment today that will be posted that you should be able to see and that is ready to go. All right, y'all? Thank you. Let me know if you have any questions.